All right, welcome back everybody. We're here for the second video on the chain rule part 3 lesson, which actually is the 5th video that we've done on the chain rule, which is section 1 of unit 3 for AP Calculus. So in this video, our entire focus is going to be on finding derivatives using numerical data. We're going to start here with example 4, where we've been given a table of values for the function and derivative for two functions, f of x and g of x, and we're going to find the derivatives of these functions with respect to x at various places. So let's go ahead and we'll do that. We'll start with part A. We're going to find the derivative of f of x plus g of x at x equals 4. This one's pretty straightforward. In order to find the derivative of f of x plus g of x, that's just going to be f prime of x plus g prime of x. And so in order to find it at 4, we're going to take f prime of 4 plus g prime of 4. And now we go to our table and look those values up. I go up and find f prime of 4. That's negative 4/5. And g prime of 4 is negative 1/3. And so we're going to go ahead and add those two together, and we get, let's see, that's 15ths, 5/15, 12/15, that's negative 17/15. Or for those of you who like decimals, negative 1.13 with the 3 repeating. All right, let's go on to part B. We're finding the derivative of f of x times g of x at x equals 1. So in order to find this derivative, we need to use the product rule. So this is going to be f of x times g prime of x plus g of x times f prime of x. And we're going to find the value of that at x equals 1. So that's going to be f of 1 times g prime of 1 plus g of 1 times f prime of 1. And then I'm going to look all those values up from the table. We're going to find them all in this column right here for 1. So let's see, f of 1 is 1/3. G prime of 1 is 2/3. G of 1 is 1. And f prime of 1 is 5/3. And so this ends up being 2/9 plus 5/3, which is going to be 17/9. Or, for those of you who like decimals, 1.8 repeating. All right, now I'm going to have to scroll back and forth a little bit when we do these last two. And you know what? I'm going to go ahead and lay them both out, and then we'll go grab the values from the table. So let's start with part C. We've got a quotient, f of x over g of x at x equals 0. So we're going to use the quotient rule. So we've got low times the derivative of high minus high times the derivative of low, square the bottom, and away we go. And since we're doing this at 0, we're going to want g of 0 times f prime of 0 minus f of 0 times g prime of 0 all over g of 0, the quantity squared. So we need all these values for 0. So I'm just going to jot those down off to the side here. All right, so g of 0 is negative 2, and f prime of 0 is 3/2, and f of 0 is 1/2, and g prime of 0 is negative 1, and g of 0 was negative 2. So we can go ahead and calculate all that, and that gives us, let's see, it gives us negative 3 plus 1/2 all over 4, which is negative 5/2 over 4, which simplifies to negative 5/8. And that's the value of the derivative of f of x over g of x at x equals 0. Okay, and the last one, part D, f of g of x at x equals 3. So this is a composite function, so we're going to use the chain rule to take this derivative. So I take the derivative of the outside, leaving the inside the same, times the derivative of the inside. And so now we, substitute 3 in there. It becomes f prime of g of 3 times g prime of 3. And we're going to go look up g of 3 and g prime of 3. G of 3 is 2 and g prime of 3 is 3. So g of 3 is 2 and g prime of 3 is 3. And now that I put that 3 in there, or that 2 in there for g of 3, now I need f prime of 2. So let's go look for that. F prime of 2 is 1/4. And so this turns into 1/4 times 3. And so the value of my derivative of f of g of x at x equals 3 is 3/4. It takes us to the end of example 4. Let's go on. We'll look at example 5. Which ties into some more stuff for us. Again, we've got the values of f of x, f prime of x, g of x, and g prime of x for some x values. Slightly different setup this time. So let's go ahead and we're going to find the value of a couple of derivatives using this. We start with h of x, which is equal to the cosine of f of x. And we want to find h prime of 1. So first we're going to find h prime of x. I need to apply the chain rule, derivative of the outside, leaving the inside the same, times the derivative of the inside. And now to find h prime of 1, I'm going to go ahead and substitute 1 in here. Makes it the opposite of the sign of f of 1 times f prime of 1. And so that's the opposite of the sign of, and now looking at my table, f of 1 is pi over 6. And f prime of 1 is 4 square root of 3. And I know that the sign of pi over 6 is 1/2. So this is the opposite of 1/2 times 4 root 3. We end up with a value of negative 2 square roots of 3 for that one. Okay. And then let's see, part B, we're finding if k of x is equal to e to the g of x, then what's the value of k prime of 2? So first I'm going to find k prime. Again, I'm going to have to use the chain rule, derivative of the outside leaving the inside the same, e to a power. The derivative of that is just e to that power. Now times the derivative of the inside, g prime of x. So k prime of 2 is equal to e to the g of 2 times g prime of 2. And now I can look both of those up in our table. G of 2 is going to be 8. And g prime of 2 is going to be 5. And so k prime of 2 is equal to 5e to the 8th. All right. One more problem we're going to do this time. Instead of using a table of values, we're going to approach it from a graph instead. We've got two functions here. The graph shows y equals h of x and y equals j of x. The solid graph y equals h of x consists of two linear pieces. The dashed graph y equals j of x also consists of two linear pieces. If p of x is equal to j of h of x, what's the value of p prime of 1? Okay, so first things first, I'm going to take the derivative of p of x using our derivative rules. P prime of x is equal to, and we're going to have to use the chain rule since this is a composite function. So the derivative of the outside, leaving the inside the same, times the derivative of the inside. And since we want the value of that at 1, it's going to be j prime of h of 1 times h prime of 1. And now we can just go ahead and figure out what the values of those are. H of 1, let's see, here's 1. H of 1 is 3, because h is the solid graph here. And h prime of 1 is the slope of the graph at 1. So I look at this point right here and figure out what the slope is there. We're going down 3 and over 1. And since every block here is counting by 1s, that tells us that h prime of 1 is negative 3. Now I need j prime of 3 to finish this off. J prime of 3 is going to be the slope of the j function at this point right here. That's on this line segment, and that line segment has a slope of negative 1/3. So this is going to be negative 1/3 times negative 3, and therefore p prime of 1 is equal to 1. All right, that takes us to the end of this video, and that's the last of what we're going to talk about with regards to the chain rule and problems associated with it. Come on back and join me for section 2 of unit 3 when we start to talk about implicit differentiation. Outside of that, have a great rest of your day, and I'll see you around in the future. Bye-bye, everybody.